Hey, what's up, everyone? I'm here with Chris Privitere. I'm Walt, and we're going to be showing you a bunch of stuff with the Equinix Load Balancer. Hey, Chris, what's up?
Hi. So we're talking about Equinix Metal Load Balancer today. So I should share my screen, shouldn't I?
Yeah, sure.
Let's do that. Entire screen.
And you actually spoke. So while you're getting that going, you actually spoke about this at KubeCon, right?
No, I talked about cloud provider KubeCon. We have one of the things we have going on is two major integrations with Kubernetes. One is Cluster API, which helps you deploy your clusters declaratively using code definitions of those clusters, and then you just throw them into a controller and it makes clusters on our platform. The other thing is kind of the component that you need on a cloud platform to integrate your cloud things that your cloud platform knows about to Kubernetes, so that Kubernetes can also know about them. And that's called the cloud provider. Ours is called Cloud Provider Equinix Metal. That's kind of what I talked about at KubeCon, but actually mostly talking about how some of the older cloud providers are getting ripped out of the core Kubernetes code, and now everyone's an external cloud provider, just like Equinix already is. So most of my KubeCon talk was not relevant to our customers because they're already good. They
Right.
don't have
Okay.
to do
So,
anything.
well, I was referring to the fireside chat that you had,
Oh,
sort of like Easter egg, the idea of hey, this is coming soon,
we
sort of
did.
thing.
Yeah, we talked. Okay, yeah.
So,
Lowdown. I
there we
forgot
go.
about that. Yeah,
Yeah.
I was thinking about like my actual speaker thing because
Mm.
that was all what was on my mind during KubeCon. The rest is a blur. Um, but yeah, there I talked a little bit about how we have load balancing as a service coming out. It's out now, and we have the integration with Cluster API now, and we have the better integration with our cloud provider. So I'm going to show you what that looks like in 3 stages.
Okay. And so what are we seeing here? Is this console.equinix.com?
This is console.equinix.com. So the first thing you're going
Whoa,
to
okay.
need is access to the console. How do they get that, Walt? How do they get started cheaply?
Okay. So the way to get started cheaply is that you use code DeployNow over here at Equinix, and then you can get started with a $250 coupon. That's $250. You can get started. And the way that you use it is you sign up on console.equinix.com, and then you use that code, and then you'll see what Chris is seeing here. And so that gives you a lot. I mean, you can do a lot with $250. You can, you know, you can deploy servers, you can destroy, try things. Yeah, so it's a little program, a little playground.
Do we have a an overlay for that?
And overlay. Yes, we do. And so I'm
Okay.
currently in the
Okay. I
process
got to
of
do
getting it
this with
for
the
you.
text
Oh,
on it.
okay,
Edit.
okay,
Deploy. Is
okay.
it deploy now? Was that
It
it?
is, yes. So there's deploy now. There's yes. So you can use deploy now, and then that will get you going. So here, let me actually do. Okay, okay. Let me see here.
Deploy
Let's
now.
go
I
see
can go
here.
bigger.
There we go. So here,
Enhance.
there's the overlay there.
What?
Oh,
I
I
don't
like
see it.
your I like your overlay
I don't see your
at
overlay. I
the
still. Oh,
bottom left.
yours is tiny. Mine's big.
Yeah.
Here, I can go bigger. Let's go bigger.
I can't really change.
Go bigger.
Yeah.
Let's go bigger.
Okay.
Deploy. Come on. Come on. Yes. Deploy now.
So if you want to, you can actually write an app that makes a text edit file and deploys this text edit. This
Yeah, because
text
that's what
edit
you want
file.
to do. Just on a website that just says
Yes.
deploy now.
Yeah.
I
Yeah.
spent I spent
Uh-huh.
all my credit. How much credit do they get?
They get $250 of credit.
Nice. All right.
Hmm.
That's plenty to do some of what we're going to talk about today. Though the the cluster I'm going to spin up is going to eat through that quickly because I'm going to spin up a number of nodes. So this is going to be kind of a production example.
Okay.
Though you can follow along, just tear everything down as soon as you're done so that you don't eat through all your credits.
Yeah. And I'm going to be asking you a lot of questions along the way because I'm sure that viewers will have the same questions.
Yes. Okay. So the first thing I want to talk about is what is the load balancer as a service offering. So if I Google Equinix Metal Load LBAS, that's what I've been calling it. Does that come up? Yeah, you get this page about our load balancers over on deployed.equinix.com, which give you a lot of technical stuff. But this is too technical. I need an easier example. So I decided to do real basic stuff. I deployed 2 web hosts into a new project on Equinix Metal. my web host and my other web host. So let's go see what's on these two web hosts. We're going to have the first one is this IP. Oh, see, it says, oh, you can't see it. Let me make it big. It says my web server.
Okay.
All right. So what does my other web host say? Copy
And your
the
web,
IP.
and so that web server could have also said deploy now.
It could have said deploy now if I had known it ahead of time. I would have said deploy
Yeah.
now.
Okay.
And this one is my other web server. So you see, if I refresh them, that's what they show.
Hmm.
My web server, my other web server. All right. So I've got two web servers. Well, what if I want to load balance? As this is a real basic example, but I want to load balance. I want to go to one IP address that rotates and goes between these two web servers on the back end. How do I do that with Equinix Metal? I know competitors have it. How does Equinix Metal do it? Well, we have a new thing over here in networking. I can go down here and go to load balancers, and you're going to see I already have one defined, and we're gonna delete that one. Just forget that because that was me testing it for this. I want to walk you through it fresh. So, load balancer. Okay, we don't have any load balancers. We need a load balancer. Let's create one. All right. So the first thing I got to do is I got to create a load balancer. My servers are in Dallas. I just know that. It's also my kind of default drop down location. So for Metro, you want to put it wherever your servers are. My host name is actually, it doesn't have to be exactly where the servers are. It can be where you want the load balancer to be. So you can have regional load balancers that are slightly different from like where your servers are. So that's actually a restriction because we're just pointing to an IP. But you choose where you want your load balancer to live. I want it in Dallas. I'm going to call it my load. No, I'm going to call it deploy now load balancer. Now that we know that our code is deploy now. I'm listening to port 80. I'm doing just insecure HTTP. I need to add some servers to it so I can create a pool right here to add some servers to it. So I'm going to go, let's see, deploy now pool. So deploy now load balancer pool. So we're very descriptive. This is a load balancer pool. What's a load balancer pool? It's a group of servers inside a load balancer. So it says, what are the pool of servers I get to direct traffic to? So it's like there's a lot of servers in the pool, and I pick you, now I pick you, now I pick you. So how do we add those servers to the pool? They're called origins in the pool. Why do we have a swimming analogy and then we have something called origins? I don't know. That's what the industry chose.
Okay.
So now we're going to add some origins to the pool. These are the IP addresses of our individual servers. So I'm going to add the IP addresses for my web server.
You know what?
and
So
my
I
other
just
web
made
server.
the actual distinction that everything is pools.
Yeah.
Pools and water, like Kubernetes, Docker,
Mm-hmm.
pools. Okay.
Yeah, we like to sail in the server
Yeah.
things. I don't know. We've been indoors for too long, so we name things about the hobbies we wish we had instead of the hobbies we do have.
I wondered if it started because of like surfing, but okay. Who knows?
All right. Well, so we're going to select an origin type. I could do any public IP address I have in Metal. We're not going to do that right here. We're going to use our convenient entry called Metal Servers and just choose my servers right off the list. So I have my web host here. Let's see, that's this one, my web server. I call it my web host in the console. Sorry, hope that's not confusing. It gives me its IP address. We're going to port 80, save, and then we're at a second one. And the second server out of Metal Servers is going to be my other web host. Here's its IP address, port 80, save. Does that make sense before I move forward?
Yes.
Okay, so we're adding the two IP addresses of the servers. Hit create. The pool has been created. The load balancer origins have been created. Now we deploy the load balancer. If you don't want to forget to press the actual deploy load balancer button. It was kind of hidden behind your portrait, but now we've deployed the load balancer. Now we have the load balancer called DeployNow Load Balancer. We can click on it. We can see it's got an IP address. Here's its IP address. It has listener ports inside that port 80 that routes to the DeployNow Load Balancer pool, which has two origins. That's the servers that are your load balancer is choosing between. You click Manage Pool here, and look, now we can look at the two servers in our pool. These are the IP addresses, this one and this one. So they're right there in the pool. They've got an equal weight. You can change this weight if you prefer one address to be preferred over the other. You give it a different weight, and then the port on that server to hit. Now, something I've learned: hard refresh doesn't work in Microsoft Edge on the Mac. If you don't know what that means, you can ignore this section. But if you are testing whether your load balancer works and you're trying to hard refresh a page and you're using Microsoft Edge and you're on a Mac and it's driving you crazy because it looks like your load balancer isn't working, try another web browser. It'll save you some trouble.
I wonder if you could use a private browser within Edge. Maybe not. I don't know. But that's actually useful about the hard reset. About the hard reload.
It's something to know about. So we'll go over here to Firefox. And remember how our load balancer gave us an IP address? Right here, 147.28.200.28. Can I make this big enough to see?
Yeah, here, let me make us smaller too. There you go.
Like I'm trying to make us as big as possible here. All right. So this IP address is our load balancer IP. I'm going to copy it. I'm going to go over here, Firefox, and I can put it in here and I'm going to hit enter. It says my web server. Okay. I'm going to hard refresh. My other web server. I'm gonna now it stopped because it's not hard refreshing anymore. So I'm gonna hold shift and hold on. Okay, there we go. We're hard refreshing. Hit the right key. So now I'm going to this one IP address and it's directing me to two different IP addresses on the back end. See, my web server, my other web server. It's hitting each about 50, half the time. All right. So that's I didn't make this big. Let me make it big and do it some more. So you can see I'm not lying. It's working.
Yeah.
All right.
Okay. Yeah.
Fair. That's real basic. That's what a web server should do. That's not surprising. What if instead of that, we wanted to take advantage of it in the context of Kubernetes?
Take us away.
Okay. This is where things get more difficult. This is where you get to see my terminal.
Yeah, could you make this larger too?
I can make it so much bigger.
There you go.
I can make it real. Deploy now. All right.
Okay.
So, do we want it that big? That's probably too big. Right?
I mean, yeah, that's very.
I'll just keep going if you want. Oh, it zoomed so much it left the screen. Well, this is unwieldy.
Okay.
I'm kind of amused by this. How does this work? Okay. So if we get clear. This is the easiest my prompt has ever been to read, by the way. I kind of like this. It may be a bit too big. To the point where I don't even know if it's functional. So we're gonna some prereqs. We're gonna do cluster API. Cluster API is a controller that you install inside a Kubernetes cluster. It's a chicken and egg thing. So it's a controller you install inside a Kubernetes cluster, and then you can interact with that controller to have it install other Kubernetes clusters for you. And then you can actually, once you've got that first cluster managing other clusters, you could migrate that stuff over and have the cluster you just deployed become the new management cluster and then own all your clusters for you. So it's a cool way of managing your Kubernetes infrastructure. It's got its own caveats. It's by no means bulletproof, but it is a way to have an environment to manage multiple Kubernetes clusters. And you usually you have a management cluster per provider. So like I would have a management cluster to manage all my AWS clusters, a management cluster to manage all my Google clusters, a management cluster to manage all my Equinix Metal clusters that are built on bare metal. So they're the coolest, right? So that's what we're going to do. We're going to set up a bare metal cluster in Equinix Metal. And why am I doing this? To show off load balancers? Well, when you have a highly available Kubernetes cluster, you have these things called control plane nodes. They're the things that do all the management of your cluster. Well, you need a way to load balance those three nodes so that if one of them goes down, you can still get to the other two. So that's why we have a load balancer in front of the control plane nodes so that you can get have some highly availability by using one IP address that actually directs you to one of 3 servers. There are multiple ways to go about getting this high availability. Traditionally, if you've used cluster API with Equinix Metal, you may have used Metal LB or kubevip or some built-in stuff with our cloud provider manually moving an IP address around to whichever control plane server it decides is the one in charge at the moment. Well, this is just a new way to do it with a load balancer technology, which is much more simple conceptually and doesn't rely on it doesn't rely on controllers running inside the cluster that it's trying to load balance to function. So
Okay, so I have a quick question. When would I use a load balancer? So let's say I'm launching a new app. Like, would that be a good time to maybe use a load balancer when there's a lot of traffic getting hit on like maybe
yeah,
one
we'll
specific
get
day?
to that in part 3 about load balancing your application. But yes, that's one of the main reasons you would, is to help move traffic on multiple nodes so that each node doesn't get overwhelmed, but also so that you can scale up the amount of traffic you can handle in total. Because usually you will have, on a Kubernetes architecture at least, you're going to have lots of pods on different worker nodes, all serving the same application, but you need a way to get your end user traffic distributed amongst all those servers. And so you would use a load balancer to do that.
Okay.
But we'll get to that use case a little bit later.
Perfect. Okay, cool.
All right, so let's start by making a cluster API cluster. So I'm not going to spend a lot of time going over the basics of cluster API. I will say you need a few things running on your machine to do it the way I'm going to do it. So I'm going to follow what I call the quick start method of, well, we all call it that. So if you go to the cluster API website, you'll see this thing called the cluster API book and something called quick start, which talks about how to just get a cluster up and running very quickly. Usually the cluster you make with this is not very production ready. I will make it slightly more production ready than you will see in the quick start guide by having multiple control plane nodes. But beyond that, this is just how to get started with cluster API. And since I'm just demoing the load balancer piece, I think it's sufficient for today. So if you're going to follow this along at home, so search for cluster API book and then quick start, and this will run you through it. The things you kind of need, Docker, kind, kubectl, and clusterctl, which is the cluster API binary for installing cluster API and managing it. So those are the 4 things you need. You're going to see Helm, but we're not going to use it much today. So, but that's, if you have that around, you're ahead of the game. Go ahead.
Perfect. And I will add all these links to the video description below. So if you're not subscribed, you should subscribe to the YouTube channel, by the way. So you should use that coupon code and also subscribe to the channel, because Chris is coming on. He was just here a couple of weeks ago doing another demo that he wrote, and he's doing this one today. So there's a lot of value here at the channel, and I'll just pass it off to Chris, but look for links below in the video description for all the stuff that Chris is walking through. So
I'm officially a value add. I like it.
Yeah.
All right. All right. So I'm going to say you've gotten Docker and kind and Helm and kubectl all installed. Because I'm not going to teach you how to run Docker today. Man, this prompt is big. So we're also going to say we have clusterctl installed. So you look at it, you get clusterctl, and you can see it's version 1.7.4 is the latest as of today. Go ahead.
Chris, we have a chat here from Steve. He says, you know what, that prompt could be a little bit bigger. Yeah, okay.
I don't know that it can.
It's like that song, Make the Logo Bigger. Yeah, this is good. Okay.
I don't know that this works at this point. All right. Now what do we got? This might be too big. Maybe let's go down a little.
And Maddie says hi. So while you're reframing that, so that you can fit more than 3 characters on a 3,000 pixel screen.
Yeah.
Then so Maddie says hi. By the way,
Maddie. How you doing?
You know, we're getting messages here in the chat. So yeah, all right. Okay, good. So yes, this is much better real estate here. I can see this.
Okay. So we're gonna do what I call clusterctl generate. What I call, like, I'm the one who named these things. So we're gonna generate a cluster. We're gonna type clusterctl generate. You may see I have some autocomplete going on in my shell. This is using the Z shell autocomplete, auto suggestion stuff. So that's why you see the gray text in the background in case you want to investigate how to do that on your own. I will try to walk you through what I'm typing rather than just taking the autocomplete without explaining it. So we're going to do cluster cuddle generate. We're going to cluster cuddle generate a cluster. So we're generating a cluster. Now we give the name of our cluster. It's going to be deploy. Oh, we're going to go with the same. So I like my text. We're going to do deploy now demo. We're going to do.
Did you want deploy now demo or deploy demo? Just so that you can.
Oh, yeah, you're right. I want deploy now demo. Let's deploy now. That's our code is deploy now. So, all right, we're going to do Kubernetes. Let's spell that correctly. Version 1.30.2, latest version of Kubernetes. We're going to do control plane machine count is 3 because we want 3 control plane nodes. We're going to do a worker machine count of 2 because we're going to load balance some services on here later. So we're going to 2 worker machines. And this part I'm going to do is going to look weird. I want you to just ignore the weird thing I'm doing here. This will change to, so what you're going to do when you get this video and watch it tomorrow, you're going to do flavor EMLB. That's what you're going to do. That's what's going to be available to you in like a day. For me, I have to do this weird command called from ghost, or I have to find a path. I have to find some local files on my machine because the release that has this new functionality technically isn't out yet. By technically, I mean it isn't out yet, and it will be like tomorrow. We're like so close to the wire on it. So
now, for people who are doing this, do they need every flag here that you're using here, or?
Oh, Walt, this is why I don't want to go too deep in the cluster API thing because they might need more flags. So I have some things pre-set up in my environment. I have some environment variables already set that you can see on the quick start guide. That so if you go down here in quick start guide, let's see, you've done all the binaries. You get to the Equinix Metal section, you do this, and then you go down and there's the other Equinix Metal section. There's a part people forget. You have to set up your project ID, your metro, your control plane type, your worker node type, your SSH key, your cluster. So we're doing cluster name on the fly, so we're good there. But you need these all set, and I have them all set ahead of time. But you might not.
Okay.
I actually don't have one of these set, so this is a good thing. So we're gonna see how we set one of these environment variables. So there's a bunch of things to worry about when it comes to doing a thing like this, and so I'm going to run this, and then we're going to export project ID equals that, and then we're going to run this code again, and it's going to give us an error because you know when I said Kubernetes. I left a space here that shouldn't be. Kubernetes dash version. All right. So now, if we look at deploy now dash demo, holy moly, is that large? All right. So we're going to go. To find the thing. So this right here is kind of a cool thing where we are defining our cluster. So inside that, so that cluster cuddle command that I ran, cluster cuddle, generate cluster, all those arguments, all that does is build a manifest for your for the cluster API controller to process and say, what kind of cluster do you want me to build? And some of the things it puts in there is what cluster API infrastructure provider, like AWS, Google, someone else, we're doing a packet cluster. If you don't know, packet was what Equinix Metal was formerly known as before they were acquired. We have not updated the names here because it would break a lot, so we need a real we want to be real careful and slow about changing names inside of the cluster API stuff, because we don't want to break your Kubernetes clusters. So that's why you'll see things like packet showing up around here. But yeah, that's what the packet cluster is, an Equinix Metal cluster. That's all you need to know. We've got the name of our cluster, deploy now demo. What namespace is the definition of the cluster living in? Don't worry about that for today. If it's a production, you might put it somewhere else. The project that we're putting it into, which is like inside your console, which project does it live in? So like Equinix LBAS demo. And then VIP manager. This is the special sauce for today. So you can see multiple choices in here like CPEM, kubevip, MetalLB, and EMLB now. And EMLB is using the Equinix Metal Load Balancer, which was our nice little example of well, my web server, my other web server. That's the load balancer. That's the thing we're showing off.
So really quick, we have a question here.
Yeah.
Jensen says here on the screen, what determines how many worker nodes versus control nodes in the
two ways to do that? So one, you can use more environment variables that there's more than even show up here. So you can use environment variables to set what your default node counts are. But I chose to today use explicit flags on the cluster cuddle command to choose it. So I have control plane machine count 3. So that's what's defining 3 machines, or worker machine count 2. So I'm going to have 2 worker machines. Now, what does that look like inside the file? We go to replicas. There we go. If we look in here, we've got metadata. We've got machine deployment for the number name deploy now demo. I'm pointing at the screen like you can see that. Name deploy now demo worker. It has replicas 2, which means 2 worker machines. And there's going to be another one here with replicas 3, because we have the kube cuddle control plane section, which has based on a packet machine template called deploy now demo control plane with replicas 3. So just like any other object in Kubernetes, you may already be familiar with pods having a number of replicas. In Cluster API, your machines are considered to be replicas. So you want 3 nodes, you have replicas set to 3. But more practically, you just define it on the command line, and that takes care of it for you, so you don't have to worry about it. Anyway, all right, cool. So now we have that.
That's a good question. Thanks, Jansen.
Yeah.
Okay.
I'm going to go over here to my kind Cappy test. So this is my locally set up cluster API management cluster. And what I'm going to do is do a kubectl apply-f deploy now demo. And wow, that's still a little big. I know the screens we need to look at next, so I'm going to have to shrink the console down a little bit more so we can see the output. So we're going to do kubectl git cluster. You can see 2 clusters here. This is a cluster I made yesterday. You can ignore that one. Got a new one called deploy now demo. It's in the middle of provisioning it. So kubectl git machines. See all these machines. These are my machines from yesterday. The deploy now demo is still provisioning at the moment. So this is the point where we have to decide how long we want to wait, or do we want to go... see, there's the first control plane node coming up from deploy now demo. So this is going to take a little bit. Like, was it 4 minutes per node or so? It'll do control plane node 1 and wait for it to be up, control plane node 2 and wait for it to be up, control plane node 3 and wait for it to be up. That's about 12 minutes there. Once they're done, actually, once control plane node 1 is done, it'll also kick off the 2 worker nodes. It doesn't have to be as careful for those, so those will go off in parallel. So overall, it'll take about 15 minutes or so for this cluster to come up.
Okay.
Do you have anything to talk about for 15 minutes, or should we just go to my pre-baked cluster in the oven to save us some time?
Well, we can go to the oven, but really quick, before we do that, let me just show really quick. We have a bunch of docs here at Equinix. One of them is on the Kubernetes cluster API that Chris was just talking about.
Yeah.
And so this is, I mean, this page is constantly being updated and things. You can see here that the page has been updated recently. But yeah, so there's a lot here that you can learn from for the cluster API and deploying a cluster API. And a lot of great docs here. And then you can also go to the Equinix docs proper. So there's more there over at our Metal doc. So there's a lot in terms of like that we've written about, a lot of code here. And, if you want to dive deep into what Chris was explaining and you want to learn more about it, we've got both our docs and our technical articles like this about our cluster API. So anything that you want to add on to that, Chris?
No, I would also recommend the Quick Start book just to get some more up-to-date examples with more current version numbers. And then what else? We've done some previous talks on Cluster API that you can use that walk you through doing the Quick Start stuff.
Okay. Yeah, and let me just show really quick about let me see if I can find that. I have the here it is. This book here. Oh, wait, it's not. There we go. Here's the book here. So this is the cluster API book that you can get started with.
Mhm.
So yeah, so I will add all these links to the video description below. And yeah, so if you want to jump to the oven, Chris,
Well,
then
let
we
me
can
show you one thing that our Cluster API deployment's already done for us. Cut back to my screen.
okay.
You see the load balancers page that I was showing you earlier. And down in here, we've got a new entry called DeployNow Demo Cap P VIP. We call the VIP virtual IP. It's the floating IP that can point to any of the control plane servers. So it's actually already created the load balancer. Unfortunately, it hasn't added any of the origins to the load balancer yet because we haven't made them yet. Actually, we got one. We just now got one. All right, we've got one. All right, this is the one I showed you earlier with my web server and my other web server. This one is the server that it is deploying right now. So the server isn't ready yet, but you can see it's already working on building up the load balancer and adding origins to that load balancer for our new cluster API cluster. And the cluster API is just taking care of that directly. And it's just making API calls for you and doing all the heavy lifting so you don't have to do anything. And you just get a load balancer for your cluster. So, yay. All right. So, to save some time, however, we're going to go over to this cluster, which is kubectl cluster info is what I meant to do. This is a cluster that I have running on this IP address, which is another load balancer IP. Get nodes. You can see, even though I've only got one IP address in for my control plane, I get 3 different nodes here. Woo! So I've got a 3-node control plane cluster that I set up about 45 hours ago. Because I can actually answer that question because it says it right here. And I've got 2 workers in here. And so we got one IP address being routed to the 3 different control plane nodes. And that's basically it. Once it's working, you're just done. Now, when you add more control plane nodes or remove control plane nodes, Cluster API will take care of adding or removing them to the load balancer for you. And so you can, when a node fails, it can be replaced and you'll still have your load balancer working. And you can grow the control plane size if you need to, and that should work too. So that's it for the Cluster API control plane example of the load balancer. Any questions on that before I move on to the more application focused one?
Yeah. So before you had those 2 different IP addresses, but then here it has that the K8's control plane is running at the single IP address. So can you explain that of like the one IP address for the control plane, yet you had those 2 IP addresses in the beginning for the web server?
Yeah. So if I were going to make an example like the web server, I would show you connecting to each individual control plane directly. and then show you another way where I'm just connecting to one IP address. So the way that looks, actually, and I don't mind showing this on stream because I'm going to delete this cluster as soon as this demo's over.
So basically, would each of those control planes be hitting a different port number on the server?
No. You hit the same. So typically we set up the kubelet, which is what handles all. Well, we set up the Kubernetes API server on port 6443 on these nodes, and that's what handles the API traffic. So we're not doing different ports or anything. But what we have is inside the file that you use to talk to a Kubernetes cluster. You might be familiar with it, called a kubeconfig file. Has a bunch of certificate info, some names, stuff about the cluster, and then this line here called server, and then an IP address for the server. Usually, you will see in a file like this, for self-made clusters with multiple nodes, you'd see multiple IP addresses here. But you don't here. You only see one IP address. So if I were trying to show you an analogous version of the demo I did earlier, I would show you a cluster that has 3 IP addresses on this server line, and then show you through some machinations the same cluster but with one address on the server line, because that would control how your kubectl commands get to your server. See, I can do it with 3 or I can do it with 1, and then I would shut down a node. Actually, I can do that demo. Ooh, should I risk doing doing failover test right now live? How risque do you want to get?
If it doesn't ruin your demo, I mean, it seems as though that we have maybe 7 minutes until the pie gets baked in the oven.
I mean, yeah.
I mean, I'm pretty risk adverse. We don't have to go.
Let's break the clusters later. Let's not break the clusters before we show off the rest of what we have to show.
I think that's a good. Maybe like
I
at
think
the end.
so. I think unfortunately, I don't have a nice, easy thing to just pound on that shows. Look, I'm connecting to this server. Now I'm connecting to this server. Now I'm connecting to this server. Usually, the way you demo that this functionality works with a load balancer on the control plane is to shut off one of the control plane nodes, and then show that it's still up and running. The way you go about breaking your control plane can lead to other things. So if you haven't prepped that demo, you may make a mistake that just breaks your cluster and it makes it look like your product isn't working when it's really because you did a bad job prepping for the demo, which is my excuse for saying, I don't want to show you that right now, but I will at the end, just to make I'm happy to put our tech to the test, but like I didn't try that before this to be ready to show it to you. So I'm a little nervous, and that's probably for the best because I'll learn something along the way, and that's always good. Anyway, so hi, let's talk about what else you can do with a load balancer, which is applications running inside your cluster. So again, we're going to stay on because actually, let me use a Kubi, by the way, is the tool I use to change contexts on Kubernetes clusters. I won't go over how to use it here, but that's if you see me easily switching between 2 different entire clusters, that's why. Let's see what I just wanted to check in. How many of our DeployNow nodes do we have? We have DeployNow. We have the 3rd control plane node. It's provisioning. The first 2 are done. We have 2 workers. Okay. All right. We can just wait a minute and use our new control plane, our new demo. Yeah. This thing's almost up and running. Let's do that.
What's the one part that's not running yet? Because it looks like that it's been running for 99 seconds.
Yeah. So see the part where it says provisioning. In this case, that means that node isn't up and running yet, and I don't really like to mess with a cluster until all 3 of its nodes until all of the planned number of control plane nodes are up and running. So it's going to be like another minute, and then it's going to kick over to running and be done. So let's see. You know what we can do? Can I do? No, I can't. So I just have to do this. There's the name. So we can just get this into this single one and just check it over and over. And then we can put the watch command in front of it. And now we have watch hitting the up arrow and pressing enter for me instead of me doing it with my hands.
Whoa, okay. Yeah, that's actually pretty cool. Okay.
And you'll see every 2 seconds, this goes up another couple seconds.
Yeah.
So we're waiting for this to pop over. So this is the most exciting part of the stream. This is where you're waiting for your cluster to finish because you're so close. So let me preface what I'm going to do once this cluster comes up. The first thing I'm going to do is install a network CNI. And that's just a necessary part of Kubernetes. Sometimes when you deploy clusters on certain cloud providers, you get a CNI as part of that deployment. Sometimes you have to add them manually. Right now, Cluster API and Equinix Metal, you need to manually install a CNI. It's very easy. I just use the default options and install Calico. But your experience may vary. You may prefer a different CNI. You can use them. Just the CIDRs and stuff inside the cluster are set up right now to be very compatible with the defaults of Calico. As you can see, our control plane node has finished. So, there's actually one thing I need to do first. Cluster cuddle, get kubeconfig for the DeployNow demo. And that's going to get that file where we can connect to the server. And there's got our load balancer address right there in the file. So I was showing you that for the other cluster. Here it is for this cluster. I'm going to put it into my kubeconfig-deploynow demo.yaml. That's just like how I like to name my files. I need to reload my shell. So the stuff I have in my shell file picks up that file exists. And now I'm going to use kubi to switch over to that new thing and do kubectl. Get nodes, and boom, the cluster we just deployed is up and running right now. It's got 5 nodes in it, 3 control plane nodes, 2 worker nodes, and now we're going to go and install a CNI. And I guess you guys get to see how the sausage is made. I've got a, let's see, install Calico. I've got a little script here that I use for installing Calico. And so I'm just going to run that script. It's just you use a kubectl create with the Calico manifest. Inside there does a curl to get the latest version number for the Calico manifest. Sets it through this JQ is part of the curl command to just get the version number, and then just applies that manifest directly into the Kubernetes cluster. And technically I should switch this create command to an apply command because the create's kind of going away, but we're just going to run it for now. So // install Calico. All right, that's applying the Calico bits. So now we're going to get pods. And this is like boring Kubernetes management 101. It's like waiting for pods to come online. And so you can see here we have all these Calico node pods. So it's a daemon set. Each node in the cluster gets a Calico node pod. And so we're just waiting for them to be up and running. As soon as they're up and running, which they are, we can now proceed onward like our cluster is fully functional, because now it has networking, so it can be, fully functional. But there's one other thing we need to do. Because so now we're getting a good part. We are going to make a web server in our Kubernetes cluster that has pods on 2 different nodes and have cloud provider Equinix Metal. Remember way back at the start of this where Walt was talking about, what was I talking about at KubeCon? Well, one of the feature functionalities we were talking about is that cloud provider Equinix Metal, for an already provisioned Kubernetes cluster, can go ahead and make service level load balancers for your applications. So before, the last example we were talking about was making a floating IP that can do failover for your clusters, for your control plane nodes. This is going to be a floating IP that does load balancing for your applications inside your worker nodes. The mechanisms for managing that are separate. The first one was managed by the cluster API controller inside your cluster API management cluster. The mechanism here is going to be cloud provider Equinix Metal, which runs inside your actual workload cluster, this cluster we just deployed with cluster API. Does that make sense?
Yes.
Okay. So the first thing we need to do then, and I have to be careful how I do this because there's going to be some API stuff on the screen if I do it wrong.
Well,
We need
here,
to,
I
yeah.
can unshare your screen.
Yes.
Do it now? Unshare?
Please unshare for a second,
Okay.
and I will tell you when to reshare, and then I'll have you unshare again.
So while you're doing that, I will show the book here.
Project ID. Let me get our project ID again. Okay. You can show the screen again.
Okay.
This is a file called cloud-sa.json. I'm in Vim. You can see the name of the file down here. Cloud-sa.json. We are setting up the secret for cloud provider Equinix Metal to use so that it knows how to talk to Equinix Metal, which is what it needs the API key filled up here, what project you live in, which is it's going to be right here. These parts you get for free. Cluster API has already set that up for you. But then we need to add some stuff in here about load balancer and what metro you're in. And we want to make sure that's all set up correct. So we're going to apply that manually with an apply command. But now I need you to unshare my screen again so I can put the API key back in here.
Okay.
Thank you.
So I'll go back to the book.
I'm so sorry. This is not the most compelling television, is it?
No, well, here. Well, I mean, what I'm doing right now. Well, so let's just recap everything that we've done as you're doing this.
Okay.
So let's go over here. You know what I should do is let me see if I can try to see
Okay.
if I can,
I'm
okay.
actually create secret generic from file. It's gonna okay. I'm ready for you to share my screen again.
Okay. All right.
We waited long enough. All right. So I'm going to show you the easiest way to update the cloud provider Equinix Metal secret in a cluster. The way you go about this is going to vary widely in your production environments because you're probably using GitOps and you need to think about how you manage your secrets there and do they live in like a HashiCorp vault or something like that. But for us right now, we're just going to delete the current secret and reapply it from a file, and that will update the secret. We'll do a rollout of the deployment. It'll pick up its new configuration values. And at that point, cloud provider Equinix Metal will be configured and ready to deploy load balancers for us. Equinix Metal Load Balancers for us. You could do different configuration settings here if you wanted it to do kubevip load balancers, Metal LB load balancers, CPEMS type stuff. But we're doing Equinix Metal Load Balancers today. So that's what I'm going to be showing you. So first thing I'm going to do is delete the old secret, -n kube system metal cloud config. This is some education. If you're using cloud provider Equinix Metal in production, you need to know like what secrets it loads and where they live. I know it lives in the kube system namespace, and the name of the secret is metal cloud config. This is the default. If you install from our examples, this is where your secret is. So we delete the secret, and then we create it. We're creating it from the file you saw me edit earlier with the same name and the same namespace. We do that, and we just got a base64 version of things, which I realize is actually technically a leak, so I'm going to have to change my API key later anyway. So that's delightful. Thank you, kubectl, for echoing that out to the screen instead of just applying it to the Kubernetes cluster. That's delightful. All right, so thank you Kubernetes. All right, so we are now going to roll out the controller. Roll out, restart, daemon set -n kube system, cloud provider Equinix Metal, kubectl get pods -n kube system. And now we're going to wait to see that the cloud provider pods are all new, which it looks like they are. And give it a second, make sure they're still up and running. So here's a pro tip for you. If you update your Equinix Metal or cloud provider Equinix Metal secret, you're messing with the config of the cloud provider. If you messed that up, these pods will start rolling, failing and going into a crash loop back off. And so it's good after you apply it and see that you've restarted the pods that they stay up and running, because that means you didn't mess up the config. You can also check the log output, but let's see, what's one of them? Yeah, here's the logs. You can see the auth token. See, here it's masked. It couldn't be masked on the other thing. Okay. Project ID, EMLB, and we see that it is, that's the part that matters for knowing how to make Equinix Metal Load Balancers. We also support, we're not doing it today, if you wanted to tell it to use a specific load balancer, that is a field you can fill in inside the config. So in case you already created some load balancers and you want to add more origins to that single load balancer, that's a thing you could do as well. But that's outside the scope for today. Okay, so what have we done so far? We created a cluster. We configured the cluster to know about how to make Equinix Metal Load Balancers and to tell it we like to use Equinix Metal Load Balancers by just using EMLB in our config. So if you remember that bits of the config, EMLB : //DA, that was telling it I want to use Equinix Metal Load Balancers and telling it what metro to put them in. And that's it. We just said we configured it. So now we need to deploy an application. So I happen to have, is that back in here? Yeah, I happen to have a Nginx deployment running right here, or defined right here, that we can deploy to our cluster. And so it's going to deploy a 3-pod deployment of Nginx using the latest version of Nginx with those containers listening on port 80. And that's real simple. And you're familiar with Nginx, right? It's just a web server.
Yes.
All right. kubectl apply -f Nginx deployment. Real easy. Oh, right. I need to create the namespace. lbas demo. So we're making a namespace for our deployment. So we're going to actually change namespace as well. We'll go into the kubectl get pods. Right now we have no pods. Kubectl get services. We have no services. So kubectl apply -f Nginx deployment. Kubectl get pods. And now we have 3 pods starting up. So we let them start. They're running. Kubectl describe deployment Nginx. There's our deployment. We've got 3 desired, 3 updated, 3 total. So we got three nodes. But right now I don't have a very easy way to show you anything on this web server because it's not exposed really outside anywhere. So we need to do expose and make a load balancer that can point you to this thing. So the other nice thing that a load balancer can do is kind of allocate an IP address that's externally accessible that people can easily use to get to your cluster without them having to hit the actual node IPs of your nodes, because usually you don't want that exposed anyway. So it's just another nice little redirection. Because you could also do a node port on Kubernetes just to expose a pod, and I could do that to show you. Here it is running on this one. Here it is running on this one. But we're just going to kind of expose this the way that we should. So we're going to deploy expose deployment, Nginx deployment, type load balancer, port 80, and that's it. We're going to do kubectl get service. We're going to wait a little bit. And right now, you see external IP is pending. So right now, if we go way back to our demo, remember when we were in the console, we had our load balancers. If you remember this from earlier, we have our cluster API, demo cap pvip, which now has 3. Remember when this only had 1? Now it has 3 behind it. See? Told you, it's real. We have another one here now called DeployNow Load Balancer, which is going to get a bunch of objects in here. So already it has 2. And those are going to have this weird thing. So something about the way we program this, we have a lot of automated, we get a lot of tags inside the cluster, like I don't know. There's some history as to how we tag load balancers in cloud provider Equinix Metal, and we use that same naming convention here for Equinix Metal Load Balancer. So I'm sorry that it, as opposed to just being DeployNow load balancer pool like what it does for DeployNow cap pvip pool, instead it's doing something nice and easy. Instead, you get cloud provider Equinix Metal auto service H1. Sorry, but
it doesn't exactly roll off the tongue.
Yeah, but for the VIP, you have a single entry per each node, which is for reasons for keeping it easier to manage when you add and remove nodes. At least here for the service, you get a single entry with all 3 nodes within it. So harder to use name, fewer entries in the list. I hope that's okay. So anyway, you'll see these 3 IP addresses here. This one's in here twice, which means one node has 2 of the pods. So anyway, you see these IP addresses. So like 147, 28, 197, 89. Remember that. We're going to take a look at our servers. 147, 28, 197, 189. That's one of our worker machines. So cloud provider Equinix Metal knows the IP addresses of your worker nodes, has set up a node port on them, pointed the load balancer at the node port on that worker machine, and that's how the magic's getting done, and your service is being hosted. Now, if we go here and do get service again, we're going to see we have an external IP. That's the load balancer IP from the other page. And just to prove that I'm not lying, let's go here. The long one. So 147.28.200.35, 147.28.200.35. And if we put that in a web browser, we get welcome to Nginx. I could do a bunch more work so it can say, my web server, but I think this is good enough for now because we've already gone an hour. Sure. But there is your load balanced application working with the Equinix Metal Load Balancers on a cluster API cluster that is also load balanced with Equinix Metal Load Balancers. Now, Walt, do you have questions for me, and or do you just want me to destroy things?
Okay. Well, there are many questions here.
Okay.
Okay. Right here, I'm seeing that you have 4 Nginx deployments here.
You're seeing the same output. You're seeing the same output 4 times.
Right. Okay.
So there.
Got it. Okay. Much better. Okay. That was my main question. Okay. Much better. Yeah. Okay. So yeah, if you want to jump over now to the oven, you were saying, or not to the oven, to the next chapter.
Well, that's the end chapter for what I'm demonstrating. Unless we want to do some proof of concepts to see how well does destroying the clusters leave us in with the load balancer. So like, let's go ahead and take bare metal servers. So we've got 2 worker nodes. Oh, right. That's why our 3 pods were distributed amongst 2 nodes. We only have 2 worker nodes. Kubectl get nodes dash o wide. So we have these 2 worker nodes. These are their internal IP. Oh, here's the external ones. 189 and 185. 1 second here. Right. Okay. So we have our 2 worker nodes. Let's start breaking things. So if we look at the load balancer.
Well, yeah, right. You wanted to break something earlier today, or
Yeah,
at least
let's
you
look
wanted
at
to
the
try
load
it.
balancer. Let's take a look at the the one with all the letters in its name. Let's look at its. Can I see its origin pool, please? Yeah. Mm-hmm. Oh, we're down to 2. Okay, so we just have the 2 entries. Oh, it must have deduped it on a later run. Okay, good. I'm glad we got that code working. All right, so we got 185 and 189. Those are our 2 worker nodes. 185, 189. We're gonna just break one. I'm gonna take 185 and turn it off. Power off. Power off. Yeah. Go ahead, stop that server. How does that react? How long does it take the load balancer? This is something I haven't tried. So like, we're still working. Okay. And if we go back to the load balancer page, go networking, load balancers, and we go to usage equals. Oh, it's already down to, oh, it pools was 1, right? We go down to, oops. Oh, come back to me, page. Come back to me. Come back to me. Go down to listener ports, port 80, manage pool. All right, does it show the status in this page? It doesn't. Okay, I was wondering if it showed status on these pages, but it doesn't. So, we look at so you can see right here, one of the nodes is marked as not ready. We get the service. We see our load balancer. If we describe the service, do we see the endpoints? Kubectl get endpoints. Is there a wide? Okay, no. I was hoping to make a more dramatic presentation, but all I can show you is I remove one of the worker nodes, and oh right, we need to do this in Firefox because we want hard refreshes. So yes, go to the HP only site. Hard refreshes are working. Okay, cool. So now the next thing I want to do. So, Walt, can you tell me what I just demonstrated? This is my quiz section for you.
Okay, yes. So you demonstrated shutting off one of the load balancers and then having the other one pick it up.
Close. Only one load balancer. I shut off one of the origins.
Correct.
And the load balancer directed my traffic over to the other one. So
yes.
Cool. Yes. So that kept my application online, even though one of my worker nodes went down. What if some of our control plane goes down? Can we still manage this cluster? So that's what I'm going to test next. So we're going to turn deploy now. We have 3 control planes. I'm going to turn 2 of them off. We're going to go down to 1 control plane. This could be real bad. I don't know how well this is going to go. So this is the part where we're going super risky.
Well, here, while that's being powered off, we have a question here from Angel.
Ooh, what's the question?
And you might know Angel because he found a company that's called Quemby, which is a very strong partner of ours here at Equinix. And so he's a question here. And by the way, Quemby spelled Cuemby. If those who are watching want to check it out. So question, is there a plan to have a global load balancer to have global load balancers same as we have global IPs that I can move around servers in different regions?
That is a wonderful question. I know it is something people are aware of the desire for, but at this point, I haven't heard any definitive plans for offering that or when or a timeline. But I will be sure to let them know that that's something people want. In fact, I'm pretty sure they already know.
Yeah, and so I mean, it's very good sales question that we can pass forward.
Yeah.
So
Unfortunately, I do not work on the team that makes the load balancers. I just wait for them to announce what they're making and see what I can do to make cluster API and other things make use of it as best it can. And I agree with you. I think that'd be really neat to have like global IPs and mix that in with the Kubernetes things, or just for the generic load balancer needs as well. So hopefully we'll get that. All
cool.
right, my servers are done or
There we go. Meant to do
down
that.
really. So let's get nodes. What do we got here? Ooh, get nodes. Oh, this is already going great.
Oh, and so he's saying that he's dying to have it. That's all.
I'm dying to have it so I can stop using FFR. Understood. So here you go, Walt. This is what happens when you do a live demo, and you didn't test all the downstream effects of what you do. I probably turned off the node running.
Well, you had two. You had 185 and 189.
I turned two nodes off, and I'm sure one of those was the master for cloud provider Equinix Metal. So that shouldn't matter much. The load balancer should still be taking care of that and doesn't care about the cloud provider Equinix Metal. But as you can see, while it's a good thing, this does not having the load balancer in and of itself does not prevent you from having an admin turn off two of your control planes and having no impact. And as much as I would like to sit here and say it does and should, you can tell because I did a live demo on stream that it did not. So this makes me sad.
Well, I mean,
kind of hoping it would just work, but
we were planning on
work. Go ahead.
But we were planning on breaking stuff, and so that's what we just did.
I did. Yeah, we broke it. Yeah, and what I don't know is if this is going to pick up as the load balancer times out those nodes on the back end, or if this is going to. Oh, you know what happened to our worker nodes? Yeah, this might be a load balancer timeout thing, so we just have to wait. Our worker nodes for the how the nodes went. We took the node down one of the worker nodes. I bet you the pod got rescheduled to the other node. I didn't think.
So you think that it's going to self heal?
I think it self healed for Nginx, and that's why we didn't have to wait for any load balancer timeouts. Here, we might have to wait a little bit before the load balancer saves us.
Okay.
Oh, I'm so nervous.
Now,
come back to me?
Let me ask: is there a way to do a watch command on this too?
Yes, there is. I'm just going to do cluster info because it's a matter of it just hitting the IP address. Yep. It's unhappy. Well, it's really unhappy. Okay. So one of the things is we went from having 3 etcd nodes to 1. So that could be the other issues. There's no etcd quorum anymore. Yeah, you're only able to take n-1. I did n-2.
So Angel,
that was a bad idea.
So it depends how you deployed. If the API server is using the load balancer IP, then it should work. Otherwise, it is because.
I'm sorry. What's the question? All right. Angel says, depending on how you deploy it, if API server is using load balancer IP, then it should work. Otherwise, is because it's using the first node IP. It is using the load balancer IP. We checked that. And we deployed the API server with that load balancer IP as I know which setting you're talking about for the control for the API server pod, what IP address it's supposed to use, because we have to plumb that IP on all the servers for that to work. So it should be working, but you know what we can do? Here's a hack, Walt. let's go to the one IP server. Copy IP. So now this is now an episode of Troubleshoot Kubernetes live on stream. So now I'm on. So I've SSH'd to the control plane server that's still up. We had 3 up. Now we have 1 up.
Yeah.
So we're going to do kubectl. Can you talk to the cluster from here? Localhost 8080. Oh, okay. So export kubectl equals etc kubernetes admin.conf kubectl cluster info. Can you talk to the local? That's weird. Leader election is pretty fast. Oh boy. Someone call raw code. Yeah, exactly. This is now clustered. All right. Is that my load balancer IP? Let's see. 200.33. Well, of course it is, because that's what the admin is going to use. Let's take a look. API server. This is the API server. Exited. Oh, give me some logs. Give me some logs about this bad boy. Logs. These are the API. Okay, I got to make this. Whoa. I don't need to make it that small, but I'm going to make it a little smaller for a second. Unexpected list and watch. Failed at Etsy. Yeah, I think this is an etcd quorum issue.
So
I don't think this is going to come back. I think I killed too many nodes, I think. But let's turn one back on. Yeah, check that IP. Check that IP. All right. Error from server forbidden unknown. No, I think it isn't an issue of the IP. I think it's an issue of the API server pod is in a crash loop. Oops. I crash looped the API server. I broke it.
Okay.
This is what happens when you get experimental live on stream. So, and it's so interesting. Like sometimes you do the kubectl cluster info, you get the IP address. You can use CTR to check the logs while the AP servers. Yeah. I'm gonna do a CTR. Oh, I hate using CTR, but I should use CTR. CTR. I like the crycuddle logs. Oh, right. If I did CTR, I could use the name. Here I have to use the ID. All right, so let's go to the top of this log. Hello. That's a lot of log, by the way. All right. Boom, 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 boom.
By the way, we're getting most of our viewership now. It's probably
people like to see broken clusters.
I was going to say
they love to see you fail. Yeah.
Well, not that people want to see something fail, but it is pretty visually captivating to see a troubleshooting stream.
Starting API server lease. Ooh, this is my favorite part of Kubernetes. Yeah.
Okay.
Sorry, I'm reading the chat. Angel says, "Ooh, this is my favorite part of Kubernetes." Yeah. Unable to authenticate the request. Oh, that's earlier or later. Can't. All right, what's this IP? 147.28.192.19.
Angel said, "This is what makes it a live stream instead of a pre-recorded video."
I know, right?
It's the magic of it. And then we can take parts of this video and upload it onto our video tab. So
them out so I don't look like a fool.
No, come on. No.
No, we need to keep that part in, Chris. That's very important. Oh, I love it. So
You don't get this
Why
far
is the server broken?
unless you know what you're doing.
This is oh man, troubleshooting etcd is not my skill set. I really don't think people want to watch me try to learn it on stream. It works great until this line.
Which line? Do you want to zoom up on it?
So if I zoom, it goes back to the bottom, doesn't it?
Oh, I was hoping that you would be able to highlight and then zoom into it, but yeah, I guess that iTerm's not letting you do that.
I mean, if it does, I might have that feature turned off if that's a feature in iTerm. I'm real curmudgeon-y about my iTerm config.
Okay. Yeah, that's all right.
Yeah.
Well, so I can actually.
The point is, it tries to talk to these IP addresses, .21.33, which is the load balancer, and then .21, which I don't know what that one is, and it's confusing me because there's no .21 on here. What's the one? What are you? Oh, the worker. Okay, yeah, it's saying the worker is down. Okay, cool. We don't care. Man.
Well, we know that the worker's down.
Yeah, because we shut it off. I think it's an issue. This is what I really want to wait a minute for this server to come back up. The other one, I brought one of the control planes back up because I'm wondering if it's just going to heal once it has enough servers to do quorum.
And what's that quorum? Because you mentioned that a couple minutes ago too.
I mean, etcd has like a number. Oh, I guess it needs 3 to agree on anything, but don't you need? I don't know. etcd likes working in odd numbers, prime numbers, so that to avoid split layering scenarios, it knows like, hey, have I lost my network versus, hey, are these servers down? Because when servers go down, it needs to know who's in charge. Because once you break, you start to deviate because someone's in charge and gets updates and the other ones don't. So how you manage that is by having thresholds for like, you need this many servers up. And they both have to agree. We can talk to each other. We're excluding the other servers we can't talk to. And whatever that threshold is for your config of etcd is going to affect whether etcd will even let itself run. So if it sees it's by itself and it knows I need at least I was in a 3-node cluster, so I need at least one more member to agree with me before we can go forward, it may be shutting itself off. But this is not my specialty, is etcd. Oh, I was right. It's back up.
No kidding. Okay. So okay.
So we needed 2 nodes to be up and running. All right.
And the 2 nodes would be the quorum because it's a majority.
Yeah.
Okay.
I was starting to question that with etcd because I could see it like being like you need all 3, but that wouldn't make sense because then you can never lose any. Just forget all that. So we needed to get 2 nodes up in this case so that Kubernetes. Oh, why did I do that? All right, so now I'm back to where I was originally. So now I'm going to do get nodes. And we can see we've got 1 not ready control plane, 1 not ready worker node. I'm on my local machine. I've exited the other cluster. So we got our 2 nodes up in quorum. We're control plane. Booyah! I should get a t-shirt that says I got quorum, says Angel. Thanks, Angel. All right. I'm so excited. All right, that worked. So I'm gonna pound this a few times. Unfortunately, I don't have like a hard refresh for kubectl, so I hope it's being load balanced properly to show that it's going to all 3, but only going to the 2 nodes that work. To show that my IP address is going to the load balancer, and the load balancer is doing the work of just excluding the down node for now. It's hard to prove. I guess we did prove sort of that. We took too many nodes and it went down, and we brought 2 back, and now it's working just fine. If I were to bring all 3, it's going to keep working fine. So that's what you want to see for your Kubernetes node, is you can lose a control plane, be going to a single IP address, and you're still able to do kubectl commands just fine. And that's what we've got working here. So I'm going to call this a success for my very risky test that I didn't plan for working ultimately after making me sweat on stream.
So I did a search. Let me see if I can fire it up. So why do quorums need to be in an odd number? And because it needs to have it needs a like majority.
Yeah.
So that's why it's only 1, 3, 5, 7, 9, whatever. So yeah, that's why there's no even numbers of cluster
And so
members.
in this case, the majority 2 versus the 1, we're able to decide, okay, we're up and talking to each other. We can agree that the one node that isn't talking right now is the down node, and we'll have to catch him back up if he ever comes back.
Yeah. Wow. Okay. That's pretty neat. Okay.
That's all I got for you. Oh, by the way, this is cute. If you check this out, make it bigger. You see this line on the kubectl get nodes output? This is the node that I shut down and that brought back up, and you can tell that's the case because it has a later version of the kernel.
Let me see.
5.15.
Right. Okay.
0116. The other ones are all 0113 because they're just straight up deployed off of what was in our image caches. But this one got a kernel update, and after I rebooted it, it's come up with the new kernel.
I was looking at the age, but yeah.
Yeah, the age is when they were created or originally added to the cluster. This is funnily enough the easiest way to say who's been most recently rebooted.
Well, that's really you took the long road on having to update your architecture.
Yeah, well, yeah, I've shown you could do control plane updates the very dirty way, which is just reboot the nodes. And yeah, you're gonna have issues with kubectl in the meantime, but eventually it's gonna work.
Sure.
Maybe do it a bit more planned. You could, corn the nodes, and then etcd will be expecting it, and then it won't be all weird like this. But we didn't do that.
All right, so then let's just wrap it up. Yeah. No, well, I mean, this is a fantastic bookend to a pretty exciting stream. Long, but really, really fun. And I learned a bunch of stuff too. So just to recap on everything. So we'll put all of the links in the video description below. My thanks to everyone and to Chris for sure. And to everyone who's in the chat and watched. I learned just as much as, I'm sure all of you. And then that's it. And then don't forget to use the code DeployNow. And I will actually throw it up over here. I was trying to find it as I was talking. But mine is, very small lower third there. And Chris got the big one up top there. So use code DeployNow. It gives you $250 of free credit that you can use towards your architecture to try some of the stuff that Chris is doing here on the stream. So that's it. My thanks to everyone, and huge thanks to Chris. Fantastic. We
thank you, Walt. It's fun.
Yeah, we just love having you on. And yeah, so a little bit of just like disaster recovery. And the demo guys were with us today, so that was pretty cool. All right,
they extracted their ounce of flesh.
Yeah. Okay, so thanks to everyone. Don't forget to subscribe to this channel for more stuff like this. And we have demo day coming up in a few weeks, so subscribe. There's a lot of stuff coming out, and videos, live streams, demo day, and docs and tutorials. And now we have YouTube shorts too, so things are growing in the right direction, and it's all for you for watching. So thanks, Chris, and thanks to everyone for watching this episode.